Hello everyone. Today we're going to be looking at bathymetry in a shoebox, where we're going to actually take the ocean floor, the features we talked about: continental shelf, continental slope, continental rise, abyssal plain, deep ocean trenches, islands, seamounts, skyouts, all the things we talked about, and we're going to try to shrink them and put them into a shoebox where we can actually use bathymetric profiling using oceanic sounding to determine the depth of an ocean that we can't see. Because believe it or not, this is all usually covered by water and pretty much invisible except for our highest of technologies. Things we've talked about before, things like the ocean, sea level, islands sticking up, continents sticking up, continental shelf, the slope and the rise, all belonging to the continental crust, and then the abyssal plains, mid-ocean ridges, seamounts, skyouts, volcanic islands, deep ocean trenches, all belonging to the oceanic crust. Then there's going to be another continent if you get over farther. But what we're going to try to do is we're going to try to take all these features, and I'm going to ask you to take 5 of them, and I would like you to put them inside of this shoebox. Okay, and your shoebox is going to look roughly like this. You're going to need to know a couple things about your shoebox. You're going to have to know your height of your shoebox, because that's going to be determined by, the scale is going to be determined by the depth of your bathymetric feature. If you're going to use a deep ocean trench, you're going to want to be able to go down 11 kilometers. If you're going to do just an abyssal plain, the number may only be 4 kilometers. If you're just going to do the continental shelf, it may only be 150 kilometers. But since we have to do at least 5, you can do the continental shelf, you can do the continental slope, you can do the continental rise, you could do the abyssal plain, you could do a seamount, you could do an abyssal hill, you could actually do a volcanic island. If you wanted to use a deep ocean trench, you're going to have to get yourself a deeper box or change your scales so that your deepest depth would be that 11 kilometers. But anyway you look at it, you're going to have to figure out a scale. Before we do all that, we have to set up the outside of our box. Now, I will tell you that I cannot draw very straight lines, so what I'm going to do is I'm going to take a couple of lines. The first thing we're going to do is we're going to determine a midline. Let me see if I can pick a different writing utensil here. We're going to determine the midline of your box, halfway between your left and your right side, longest dimension, and we're going to try to draw a line. And don't laugh too much, because this line will not be straight, but it's close. That's going to be your midline. Next thing you're going to do is you're going to actually take your ruler, and you're going to measure 2 centimeters on either side of the line, and you're going to draw another line. Not too bad. 2 centimeters on this side, you're going to draw your third line. So we've got the midline, which for all intents and purposes we're going to ignore right now, and then we've got these lines. The way the lines will actually work is that you're going to label these lines 2 different things. We're going to call one line A, we're going to call the other one line B. Whichever one you call doesn't really matter, but let me pick a different color. I'm going to call this one up here line A. So this one's going to be our line B. And then we're going to measure 2 centimeters from the edge, and we're going to put a hole. You can use a pen. I'm going to see if I can find some drawing compasses. Maybe we can draw with that. But you're going to draw 2 centimeters, and then you're going to draw, that's not a very good color. You're going to draw a small little, or you're going to actually put a hole there. You may want to draw it first. Another 2 centimeters. Another 2 centimeters, another 2 centimeters, and you're going to keep going all the way to the end. Every 2 centimeters on your box. And you're going to do that for both lines, A and B. And then go down here and do the same thing. And again, 2 centimeters. And then you're going to label each one, starting with one end. I guess it doesn't really matter which end, but I'm going to start with the end that I actually started drawing, because I like to go left to right. And we're going to call this one up here This is going to be A0. This one is going to be A2, A4, A6, A8, and I think you can get the idea. And this one will be B0, this will be B2, this will be B4, B6, B8, continued all the way over to the side. Next thing we have to do is we have to open up our box, and we'll come back to this picture in a second. And I would like you to do the same thing on the inside of the box. I would like you to determine sort of the midline, and then I want you to measure 2, maybe even 3 centimeters, and I want you to draw lines from one side to the other. And this is going to be the area where you're actually going to design your ocean floor. You can sort of imagine coming up like this, and up this side, and this is where you're going to design your ocean floor. You're going to design it so it looks something like this, and you're going to make it out of your flour Play-Doh. So if you're going to do an abyssal plain somewhere between 3 to 5 kilometers deep. Continental shelf, 150 meters deep. Continental slope down to somewhere between 2.5 to 3 kilometers. Guess I should put those down there. You're going to have mid-ocean ridge, which comes off whatever your basin is up to whatever height you want. You could bring it all the way to the surface and make islands out of it. You're going to have seamounts, anything over 1,000 meters or a kilometer tall. Remember, if they're smaller than that, we call them abyssal hills. You can make flat-topped underwater guyots. You could make mid-ocean ridges, which go all the way down to 11 kilometers deep. You can make islands. You can make whatever features you want. You just have to have 5. Okay, so then you're going to go back into your box, or back to your box, and you got to calculate the right size of your box, the height of your box. And remember, your deepest bathymetric feature is going to be the box bottom. The tallest one is going to be on the box top. Now, if this was an ocean, what would the box lid actually represent? It's going to represent sea level. You can see it up on this box. So you may have everything underneath this box lid, everything underneath sea level, like all these. You can actually even have one going up. That's going to take a little bit more creation, because you're going to have a piece of it sticking up out of the box. So it would actually you'd build it from the bottom all the way up, and then add a little bit more up toward the top. So here's your shoe box. This is where you're going to design it. But how do you do that? Well, something like this. And maybe I'll start drawing it here. Let's say this box is 9 centimeters high. Let's say the deepest thing I want to make is an abyssal plain. And again, I can make this anywhere between 3 and 5 kilometers deep, or 3,000 to 5,000 meters deep. Let's say I want to make it 4,000. I'll split the difference. So 4,000 meters deep. What we have to do is we got to figure out a scale. To figure out this scale, we got to figure out the depth of our water. Okay, and we're going to have 4,000. We're going to divide it by the height of our box, which is going to be 9. And what we're going to get here, this is almost 10. A little more than 4, and then there'll be 1. It's going to be 440 meters per centimeter. So every centimeter you see here is going to be 440 meters. So there'd be 888 meters. It just keeps going all the way up until you come all the way up to 9, which would get you back up to your 4,000. Now this is depth again. Remember, you got to start with 0 at the top, and then you're going to go all the way down to, in this case, 4,000. I'm going to do an abyssal plain, all the way down to the bottom, 4,000 meters. And you're going to want to remember these things are in meters. Okay, so this is depth. So this would be 4,400 meters from the bottom. This is 4,400 meters from the surface. Depth is from the surface. So you're going to use this, and this is going to be your scale. I would really like it if you guys could take that scale and write it very obviously on your box, someplace on the top. Something like scale equals 444 meters per centimeter. Make that really obvious. Don't take up the whole surface, but make it real obvious. You can actually draw boats from the top if you wanted to. You can draw sea creatures swimming on it, because again, this is the surface. You can do whatever you want, but make sure this scale is relatively easy to see, because you're going to be giving this to another group next class, and they're going to try to figure out what's actually in your box. The next thing you're going to do is you're going to try to design your clay model. Again, in this case, this bottom of the box is going to represent my abyssal plain, so I may want to put a mid-ocean ridge. You got to calculate how tall it is. Let's say mid-ocean ridges are going to reach up to 1,000. If you actually did that, you can calculate it from the surface down, you can calculate it from the top up. But let's say it reaches 1,000 down, so that's going to be a little bit more than 2 centimeters from the surface, the top of the box. So I'm going to have to build up a whole bunch of this Play-Doh to actually build that up. C-mounts, if it extends 1,000 meters up, that's going to be a little more than 2 meters from the bottom of your box. If you're going to build an island, it's going to go from your bottom of your box all the way to the top of your box and out. If you're going to go down to 150 meters, that's going to be way less than a centimeter, somewhere around 1/3 of a centimeter. So you're going to be really close to the surface, going down to about 1/3 of a centimeter to make your continental shelf. And then you're going to slope it down to 2.5 to 3 kilometers, and then you're going to actually make your abyssal plain. Then you can make a mid-ocean ridge, you can make abyssal hills, you can make seamounts, you can make guyots, you can make whatever you want, but you got to use the scale. That scale that we determined right there is going to be the scale for everything that goes in your box. Okay, the last thing you're going to do, one of the last things you're going to do is I'm going to give you a coat hanger. We're going to straighten the coat hanger out, and then I want you to actually make marks every centimeter on here. Every centimeter is going to represent whatever your scale is, if it's 444 or if it's 1,000 or it's 823, whatever your scale is going to be. The people next class are going to use this thing to put through your holes, like hole A0, and they're going to try to calculate how deep the water is under that, and then B0, how deep it is under that. And we're going to come up with something that's called a bathymetric profile. It's going to represent something that looks like this. So they'll put it under A0, and let's say this one right here is our A0, and here's our A2, and our A4, and our A6, and our A8, and our A10, and all the way across. We're going to take that clothes hanger, we're going to drop it down, and it's going to say it represents a certain depth. We're going to use that scale times the number of centimeters, and we're going to calculate how deep it is. And then I'm going to have you guys make a bathymetric profile. The people designing the box are also going to make a sample bathymetric profile, and they're going to actually tape it to the side of their box. It will not be visible from the outside, but once the box is open, so that the people who actually do the bathymetric profiling of your box can take a look and see if they got it right. They can compare it to your map by taking it out. But you guys are going to be making a bathymetric profile of someone else's box. So we're hoping that this thing works out really well. Here are a couple examples of a bathymetric profile in terms of continental shelf. And you can see it actually is really close to the top of your box. Slope goes down to roughly 3,000, maybe 2,800 meters. Continental rise very wide, going all the way down to a little more than 4, maybe 4,500 meters. This is one off Cape Hatteras, 35 degrees north. If you go down a little bit closer to the equator, down by South Carolina, you can see that they actually have a much different kind of a slope down to the abyssal plain. What you do is totally up to you. I would not recommend doing something like this because it's going to be relatively hard for someone to actually see this in your box. Try to make it as easy for them as possible. Again, you've got to take 5 bathymetric features. You're going to actually design the inside and the outside of the box, and you're going to line the box, making sure you've got a scale, and you're going to actually put it inside the box. I'm going to give you a piece of wax paper to try to keep the cardboard from absorbing all your moisture and then turning into a very sloppy mess. But you're going to actually try to make a bathymetric profile of an ocean floor, fictitious probably, but a bathymetric profile of an ocean floor inside your box. It's a Bathy Shoe bathymetric map. So, with that being said, here we go. Bye-bye.